Hi all, welcome to my record. So in this case we are running an ML workflow which will be able to predict the net hourly electrical energy output. We have our data is related to the combined cycle power plant. These are all the features. From these features this is a target target feature. So how did I do it? First I'll just go through the questions. The first question is which type of machine learning approach did I use. So in this case we were predicting something. So this is a regression model where we are able to use the existing data to predict the values based on the existing data. So this was a regression model. The next question is how many possible features you want to use. So I used all the available features which were given to us. So 1 2 3 4 5, these are all the features that we had. So but this was a target feature, so this was excluded and these were all run. Once this run was complete, we got the target feature output value also. The next one is split. How was the split done? In Google AutoML there is a random split. So by random it does 80% training set, 10% validation and 10% test. This is how we did it, and I used Google AutoML for model building. The last one is validation approach, compare at least two models. So in my case the two models were the first model that I just discussed, which had all the features. Once my first model was complete, I noticed that temperature was the most prominent factor affecting the target feature. So in the next model run I kept everything the same, but I changed this. I removed temperature and I reran the model, and we got different values which I'll just show shortly. The last one is evaluate the performance of your final model. I'll show it to you right now. So when we go to my Google account, this is how a completed model run looks like. We have a target column, we have all the features here. This feature, which is temperature, is the most prominent one. This affects majorly the model output, and you see this is the output accuracy. So 96% is the accuracy that we can expect from this data set. This was the first model and the best model. Now to compare it to the second model, what I did was I removed temperature. So how did it look like? The next model is this one, where vacuum becomes the most prominent feature. So once you remove temperature, vacuum is the most prominent feature. Your target column remains the same, which is the energy output, but your accuracy changes. In the first model we had an accuracy of 96%, but in the second model we have an accuracy of 91%. And just to mention, when we are running this on a supervised data set, what two options we have are regression and classification. So in our case, classification was not really useful. What we wanted to do was predict the model output, so I selected regression, and this is how we got the prediction. Thank you.